Welcome back to Scholar Strife doing some math. Today we'll be trying to find rational zeros. So we have a large polynomial and we want to figure out um, all the zeros or the intercepts of the function. So normally we had, you would factor if it was easily factorable. We had the quadratic formula for quadratic equations, but now our polynomials get bigger than that. So here's an example. Find all the real zeros of x cubed minus 8x squared plus 11x plus 20. Right now, all we can do is guess and then use synthetic division. So that's not useful for us. I mean, we just plug in 1, 2, 3, and we're most likely not going to find the right guess because in the next example, we have this, and the zeros are fractions. That's really hard to guess. But someone figured out, I don't know how, but there is a pattern to these zeros in the second equation. So the numerators, so we have -5, -3, and -7. So the numerators here, which are factors of -105. So that's the constant. Okay. And the denominators, 2, 4, and 8, are factors of 64, the leading coefficient. And then they figured out the rational root 0 theorem. So if you have a polynomial, so this big f of x thing, has integer coefficients, which means non-fraction, then every rational zero of the function has the following form: p over q. So the factors of our constant term over the factors of our leading coefficient. So where every p and q combination will be all the possible rational zeros, but not all of them are the actual zeros. So remember, if we have an x to the fourth, oh, that looks terrible. If we have an x to the fourth, the maximum amount of zeros we can have is 4. If we have an x to the fifth, the maximum amount of zeros we can have is 5. But we can have imaginary zeros, we can have, or we can have the same number happen multiple times. So every p and q combination is not all possible zeros. All right. Okay, now it's time to mind your p's and q's. So remember, p is factors of my constant. So factors of 15. Okay. So 1 goes into 15, 3 goes into 15, 5 goes into 15, and 15 goes into 15. And then we got to put all the negative values in there because -1 times -15 is positive 15. So we have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. And then we look at q, which is the factors of our leading coefficient. Our leading coefficient is the number in front of our highest degree, which is just 1. So plus or minus 1. So we're going to do p divided by q. And, well, this one's easy because since my q value is 1, all these values divided by plus or minus 1 is still the same. So my p divided by q is plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Okay? So this is a cubic. That means there's at least 3 possible zeros that we can get. So we're going to use synthetic division on one of these factors until we find one that works, and then factor to find all the zeros. So here we go. We're going to try 1. So positive 1. And then my coefficients 1, 9, 23, and 15. Whoop. So these are the coefficients of my equation here. Okay, drop the first number down. 1 times 1 is 1. 9 times 1, 9 plus 1 is 10. 10 times 1 is 10. 33. And we can tell that this is not going to be 0. So the remainder is not 0. So x minus 1 is not a factor. Okay. Now we're going to try negative 1. So yes, sadly, we're going to try every one of these until we get one of them. So 1, 9, 23, 15. 1. But this is pretty easy multiplication here. So 1 times negative 1 is negative 1. 9 plus negative 1 is 8. So we get negative 8. And we get 15. And then negative 15 plus positive 15 is 0. Okay, we got a remainder 0. So the remainder equals 0. So x plus 1 is a factor. Okay. So x plus 1 is a factor. And then remember, these numbers here are the coefficients of my other factor. X squared plus 8x plus 15. What is that? There we go. Okay. Next. Factor. Even more. We gotta find all our zeros. So setting this equals 0. So we have, well, this is x plus 1 equals 0, so this is x equals negative 1. And then this factors into, so two numbers that add up, they're multiplied to 15 and add up to 8. That's 5 and 3. So this is x equals negative 5. X, send to the back. X equals negative 3. And that's my 3 possible zeros. Alright. Alright, so what happens if we have a leading coefficient that's not 1? It just takes a little bit longer. You might have to work with fractions. But here we go. So we have this function here. 3x to the 4th plus x cubed minus 10x squared plus 2x plus 4. So we need to find our p factors. P is the factors of our constant, which is 4. So 1, 2, and 4. And then we have q, factors of our leading coefficient, 1 and 3. And then we set up every combination. So 1 over 3, 1 over, or 2 over 3, 4 over 3, and then 1 over 1, 2 over 2, or 2 over 1, and 4 over 1. So I'm just taking every p value and then putting it over q. And do we really want to try all these combinations? Because there's 1, 2, 3, 4, 5, 6, 12 different possible combinations. That's a lot of work. Not really. So, I meant not really as in we don't want to do these. Graph the function on a calculator and then estimate the values of which might be roots. Now, if you already have a graphing calculator, you might as well tell your calculator what are the roots, and it'll find it for you. But if you graph it, you'll be able to estimate which roots are most likely your zeros. So we're going to try P over Q equals 1. Guess what? It's going to work, but show your work. So we have the coefficients of my function, 3x to the fourth plus 1x cubed minus 10x squared plus 2x plus 4. Drop 3 down. 1 times 3 is 3. 3 plus 1 is 4. 4 times 1 is 4. That's negative 6. That's negative 6. That's negative 4. And then negative 4, 0. Okay. So we know this works because the remainder equals 0. So remember, this is the opposite, not positive 1, but x minus 1 here. I mean, x equals 1 is, x equals positive 1 is the root. But when we factor it, it's x minus 1. And then what we're left with is these coefficients right here. So 3x cubed plus 4x squared minus 6x minus 4. Can we factor this big mess here? We can try by grouping, but no, we can't. So we're going to take this and we're going to use our P over Q's, and we're going to try a different number. So this suggests to try negative 2. So my new coefficients are going to be from up here. So these guys. So this is my 3x cubed, my 4x squared, my 6x, minus 6x, and then my minus 4. Man, my pen is being very finicky today. So I'm going to drop this down. 3 times negative 2 is negative 6. 4 plus negative 6 is negative 2. Negative 2 times negative 2 is positive 4. And that still gives me negative 2. Gives me another positive 4. So 0. So this remainder works. So this is x plus 2. So I'm going to bring back my x minus 1 from before. My x plus 2. Okay. And now we shrunk down our function a little bit more. So this is 3x squared minus 2x minus 2. Okay. Now we got to find all our zeros. Can we factor this? If we could, the closest thing would look like this. 3x, x, combination of negative 2 that adds up to 2, negative 2, plus no. So how do we factor that? We don't. We use the quadratic formula to find out what the rest of our zeros are. So looking at these, we have x equals 1 and x equals negative 2. And now we're going to use the quadratic formula to find the rest. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So my a value, so I'm looking at, let's use, can I highlight? Is this highlight? There we go. Using that there. Oops. So here's my a value, my b value, and my c value. A value is 3, b value is negative 2. C value is also negative 2. So I punch this into the equation here. X equals negative, so positive 2, plus or minus the square root of b squared, which is negative 2 squared minus 4 times a times negative 2 all over negative 4, which is 2 times a. Oh, so sorry, 2 times a is 2 times 3, which is 6. And then we have x equals 2 plus or minus the square root of 28 over 6. Okay. And then we're just going to reduce this. So this is 2 plus or minus 2 root 7 over 6, which is equal to... So remember, this is 2 over 6, which is 1/3, plus or minus 2, plus or minus, please, root 7. Come on. 7. Let's see if I can do it this way. Okay, there's a 7 there. So, once again, my zeros are x equals negative 1, or x equals positive 1, sorry, x equals negative 2, and then x is plus 1 plus or minus the square root of 7 over 3. Okay, so let's back up. Let's make sure this is right. Our example is of degree 4, and I have 4 possible roots here. Remember, this last one is 2 with the plus or minus. So, there we go. Alright, one more example, okay? So, P is my factors of 42. So, plus or minus 1, plus or minus 2, plus or minus 3. Yep, 3 goes in there. Plus or minus 6, plus or minus 7, plus or minus 14, plus or minus 21, plus or minus 42. Yeah. And then Q. Or you should use lowercase, but so Q is factors of my leading coefficient 2. So plus or minus 1, plus or minus 2. So my P over Q values is equal to all these, all my P values, because if you divide it by 1, you get all those values. And then if we divide everything by plus or minus 2 here, the other extra ones is plus or minus 1/2, plus or minus 3/2, plus or minus 7/2. 14 divided by 2 is 7, and then we have plus or minus 21/2, and then 42 divided by 2 is 21. So not only do we have these up here, we have these. So many numbers. It's kind of ridiculous. But we'll skip ahead. Let's say we graphed it, or we're like, oh, negative 2 works. So let's, oops. Negative 2. So our coefficients are 2, 5, minus 18, minus 19, and 42. So 2 times negative 2 is negative 4, 1, negative 2, negative 20, 40, whoa, whoa, stop. Oh, where'd my pen go? This was negative 19. This was positive 40. And we get 21. And then we get negative 42. Add together, we get 0. So x equals 2 works. Obviously, we're not going to be able to factor a cubic. Well, maybe it comes out nice, but it doesn't. So we're going to try. So we actually find out it's 1.5 or 3/2. So here is, so remember, we're using this one here as our coefficients now. So we have 2, 1, negative 20, and 21. So I plug that in. So I drop down the 2. 3/2 times 2 is 3. Get 4. 1.5 times 4 is 6. Get minus 14. 1.5 times negative 14 is negative 21. Look at that. Nice. So we have x plus, well, hello, plus 2, please. X minus 3/2. And then we have our coefficients here. 2x squared plus 4x minus 14. Can I factor that? No. So, quadratic formula. So this is a lot of work, guys. Quadratic formula. So negative 4. Remember, this is a, b, c, plus or minus the square root of negative 4, or sorry, positive 4 squared minus 4 times a, which is 2, times c, which is negative 14. All over 2 times 2. And this will simplify into negative 4 plus or minus 128 all over 4, which will simplify to 64 times 2. Okay. Negative 4 plus or minus 8 root 2 over 4. So I get, so here I got x equals negative 2, x equals 3/2, and then this will be x equals negative 1 plus or minus 2 root 2. Alright, that was pretty difficult. If you need help, please come in for lunch or whatever. Or watch this video like 50 billion times.